So welcome back to part 2 of the lesson. So we already finished the core concepts in the previous lesson for finding the values for the side length of special right triangles. So here we have a special right triangle that is a 30, 60, 90 special right triangle. I have the length of the hypotenuse, which is C, and I am looking for the length of the adjacent side. So I'm going to use my special right triangle. So let's go ahead and draw the relationship here for my special right triangle. So here's my 30-degree angle, my 60-degree angle. So I know that the shorter side, which is opposite to the smallest angle, is going to be A. The hypotenuse is twice that length, and the longer leg is going to be A times the square root of 3. So let's see in our given example what we have. So in our given example, we are given side C. So side C is the hypotenuse, and so we are going to say 2 times A is going to give me 8. Therefore, the shorter leg is going to have a length of 4, which is half of the 8. So I know that this length here is going to be 4. This would be my shorter leg. Now from here, I need to figure out what the longer leg would be. So I'm going to write here just so you can see that first we figured out the shorter leg. Now we are going to figure out the length of the longer leg. So we know that the length of the longer leg, x, will have to be equal to a times the square root of 3. So from the previous part, we already figured out what a would be. So I'm going to substitute, and I'm going to say x will equal to 4 times the square root of 3. So this would be the exact answer. Now we are going to punch this in our calculator because it's asking us to run to the nearest hundredths place. So we are going to have x is approximately 6.93. So this is the approximation of the answer because this is a rounded figure, and the exact answer, so let me write that down too, exact, and then this is approximation. In the answers. In the previous example, I recognized the fact that it was a 30, 60, 90 special right triangle, so I could use the relationship between the side lengths. However, in this problem, when I need to solve the right triangle ABC, I am not given a special right triangle, so I will need to use my trigonometric ratios. When we are asking to solve, or we were asked to solve the triangle ABC, that means we have to find the measurement of every part of the right triangle. So I'm going to first write the measure of angle B I need to find. I already know that angle C is going to be 90 degrees. I also know that the measure of angle A is 28 degrees. So I need to also find the length of side A. I already know that B is 15, and then I need to find the side length of C. So I will create myself some workspace on the right hand side, and I will use a different color to do my work, so that way I can then go back and fill in my answers on the left hand side. So I know that the sum of the angles of a triangle is going to have to be 180 degrees. So the sum of the measures of the three angles, so measure of angle B plus the measure of angle C plus the measure of angle A is going to have to be 180. I don't know the measure of angle B, but I know that C is 90 and measure of angle A is 28 degrees. So all I have to do is solve the equation. So the measure of angle B plus 118 will equal to 180 degrees. So the measure of angle B will be 62 degrees. So I can say that that is 62 degrees. I can also put that into my triangle. So now I need to figure out some of the other measures. Since I'm given the adjacent side here to the angles, so to the angle 28 degrees, I am given the adjacent side. I am going to use the tangent ratio to figure out the length of the opposite side. So I will write the tangent of the 28 degrees, which is angle A, will equal to the opposite, which is A, divided by the adjacent side, which is 15. So now if I multiply both sides by 15, I am going to get A equals 15 times the tangent of 28. Punch this in your calculator. Before you can punch that into your calculator, I would like you to press the mode button and scroll down to the radian/degree. Make sure your degree is the one that's highlighted and enter twice so you can enter this now into your calculator. The value of A will be approximately, so I change the equal to approximation. It's going to be 7.98. So now we have our side length, which is approximately 7.98. Now we are going to have to find the length of the hypotenuse, which is C. So I need to either use my sine or my cosine ratio. I prefer to use the whole numbers in my equations and the ones that were given to me originally. So I am going to use the 15 for the side length of B, and then I'm going to use again the given information, which was the 28 degrees. So I need to find side C. So I will say cosine of 28 degrees is the adjacent side, which is 15, divided by the hypotenuse, which is C. So I need to be able to solve for C. So what I'll do is I'll multiply both sides by C. Then I get C times cosine of 28 degrees equals 15. And last, I am going to divide by cosine of 28 degrees. So C will be approximately 16.99. So now I have the length for C, which is 16.99. I can write these two numbers in my answer column on the left hand side. So my A is 7.98 and my C is 16.99 when I run to the nearest hundredths place. On the next page, you have 5 monitoring progress problems. So before you move on to the next page to check your answers, please work them out on your student handout. Now let us look at some application problems. For example, example 5. You are hiking near a canyon. While standing at point A, you measure an angle of 90 degrees between B and C as shown in the diagram. You then walk to B and measure an angle of 76 degrees between A and C. The distance between A and B is about 2 miles. How wide is the canyon between A and C? And round your answer to the nearest mile. So let us look at the problem. The unknown that we would like to find is the distance between A and C. So here I am going to label that with X. So in relationship to the given angle 76 degrees, this is my opposite side. And I am also given the adjacent side. So if I think of my trigonometric functions, opposite and adjacent is the tangent ratio. So I'm going to say tangent of 76 degrees will give me x, which is opposite, divided by the adjacent, which is 2. So now when I solve this, I multiply both sides by 2. So x will equal to 2 times the tangent of 76 degrees. Let us punch this in our calculator. So x will be approximately 8.0215. However, we need to run to the nearest mile. So my answer here will be the distance between A and C is approximately 8 miles. So here is my final answer in the rounded figure. Here is another application problem. A parasailer is attached to a boat with a rope of 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. Run to the nearest foot. So let's go ahead and mark the information given to us into a diagram. So we know that the length of the rope is 72 feet. We also know that the angle of elevation from the boat to the parasailer, so that means I'm going to make a right triangle and put the right angle from the parasailer to the ground, and the angle of elevation from the boat to the rope or to the parasailer is going to be that 28 degrees. What I need to find is the height of the parasailer, so that means from the boat to the parasailer I need to find that distance. So again, I'm going to look at what kind of sides of the triangle and are given to me in relationship to the angle. So I look at the x, which is opposite the angle 28, and the 72 is my hypotenuse. Therefore, I'm going to use the trigonometric ratio that involves the opposite and the hypotenuse. So the sine of 28 degrees is going to be x divided by 72. So let's multiply both sides by 72 to solve for x. So x will equal to 72 times the sine of 28 degrees. Let's punch this in our calculator. And we get x is approximately 33.802 feet. Then we have to run this to the nearest foot. So our answer will be the height of the parasailer is approximately 34 feet. The next slide will contain some monitoring progress problems. So please work on your next page on your handout before you move on to see your answers. See you in a couple of days for lesson 8.2.